In this video, we're going to review ketone bodies, which is an energy substrate that our bodies use, especially when glucose is in short supply. Our bodies prefer glucose for energy. Immediately after you eat, you absorb sugars and carbohydrates, then you break down those carbohydrates into glucose and run the glucose through the glycolysis pathway to make acetyl-CoA, which then gets used in the Krebs cycle or the TCA cycle. So far, so good. Now, as the glucose supply from your last meal runs out after 4 to 6 hours, the liver is responsible for maintaining serum glucose levels by two mechanisms. There's gluconeogenesis, which is the synthesis of glucose, and there's glycogenolysis, in which glucose that was stored as glycogen is now released from storage. But as you get farther and farther from your last meal and your glycogen stores become depleted, the liver starts making ketone bodies, which is a process known as ketogenesis. So in the liver, fatty acids and amino acids are metabolized into acetoacetate, which is a ketone body. And then you can use NADH to turn acetoacetate into another ketone body called beta-hydroxybutyrate. So you need to be able to recognize those two substances as the main ketone bodies, acetoacetate and beta-hydroxybutyrate. And then lots of different tissues in your body, like muscle and brain, can use those ketone bodies for energy when there's not enough glucose around. You should also know that the rate-limiting enzyme in ketogenesis, the synthesis of ketone bodies, is HMG-CoA synthase, which converts acetyl-CoA to HMG-CoA. And then the enzyme HMG-CoA lyase converts that HMG-CoA to acetoacetate. Now, don't get these enzymes confused with HMG-CoA reductase, which is the rate-limiting enzyme in cholesterol synthesis. So, when would you start generating ketone bodies? Well, it's basically whenever you break down so many fatty acids and make so much acetyl-CoA that the TCA cycle can't handle it all. So you're going to start making ketone bodies. Now, think about people who go on an extreme no-carb diet like the Atkins diet. They want to start burning fat. They want to start breaking down fatty acids. They're trying to become ketogenic. So whenever there's prolonged starvation or a very, very low-carb diet, you're going to use up all your oxaloacetate because of gluconeogenesis. So using up all your oxaloacetate, you're depleting oxaloacetate. And as you deplete oxaloacetate, the TCA cycle has to slow down. So you're redirecting TCA cycle metabolites toward gluconeogenesis. So in times of excess gluconeogenesis, you're going to actually shut down the TCA cycle. When you shut down the TCA cycle, you're going to start making ketone bodies. And not only can acetoacetate be converted into beta-hydroxybutyrate using NADH, acetoacetate can also spontaneously become acetone. So as acetoacetate becomes acetone, patients that are making a lot of ketone bodies are going to have a slightly fruity smell to their breath from the acetone. That's one of the things you might notice in a patient that's in diabetic ketoacidosis. Another important point to know is that when you test for ketones in the urine of a DKA patient, you're actually only testing for acetoacetate. The urine test for ketones does not test for beta-hydroxybutyrate. And that's it for now. I'll see you next time.